So in this problem we have two batteries and each of them has an EMF of 1.5 volts. And the two batteries are connected in series. So here we're going to draw the two batteries like this. And each one of these batteries has an internal resistance. So the internal resistance of this top one is 0.255 ohms, and this is the internal resistance of the bottom battery, 0.153 ohms. So if we connect the two batteries in series, like this, then they form a circuit, and there's a light bulb connected to the circuit in series. So this light bulb has a resistance, and then we are told that there's a current flowing through the circuit. That's what lights up the bulb, and the current is 600 milliamps. So now consider these points A and this point B on the circuit, and we want to find what is the potential difference between points A and B. So that's the same as the potential difference across the bulb. So the potential difference is the sum of all the potentials, the potential of the first battery plus the potential difference across the first resistor, which is just the current times the resistance of that resistor, plus the potential difference across the second battery, 1.5, plus the potential difference across the second resistor, which is just the current to that resistor times its resistance. So we have this expression for the total potential difference across the light bulb, which is the potential difference between points A and B. So in this expression, the only variable that we need to plug in is the current, but we know that the current in the circuit is equal to 600 milliamps. So all we have to do is plug in this number into the expression for the potential difference between points A and B. So here we plug in 600 milliamps into this equation for I. We have to put milliamps, so 10 to the minus 3 here. And now we just have to evaluate this number. So we find that the potential difference between points A and B is this, once we multiply out and add all these numbers. So this is the potential difference between the two ends of the light bulb. So that means that the potential at point B is, so let's draw how the circuit looks like here. We have the two batteries, we have points A and B, and this is the light bulb over here. The current is flowing in this way. So the way we've calculated this potential difference, we find out that point B is 2.755 volts higher than point A. Okay, so that's the potential difference between those 2 points, but point B is at a higher potential than point A. Now the potential difference between points A and B is equal to the potential difference across the light bulb, which is equal to the current through the light bulb times the resistance of the light bulb. So we know what the potential difference is, and we know what the current is. So now we can find out what the resistance of the light bulb is. We just solve for the resistance of the light bulb in this equation. So the resistance of the light bulb is just this number right here. And if we calculate it, we get this. So we have 4.592 ohms for the resistance of the light bulb. Now, in the second part of the problem, we want to find the total chemical energy transformed by one battery. Well, in one battery we have, well, the chemical energy. Chemical energy transformed is just equal to the power that this battery delivers. The power is voltage times the current. So one battery delivers this much power. Okay, that's how many watts the battery is delivered. So for the two batteries we have twice as much. So this is the total power delivered by both of the batteries. Now some of this power, some of this energy per unit time is burned out at the resistors, at the internal resistors of the batteries. So the total power delivered to the resistors is just the current squared times the resistor of each battery. So we can write it out like this. And we know the current in the circuit, we know the internal resistance of each of the batteries. So when we add them up, we get this number. Now if we consider this as a fraction of the total power that the batteries are delivering to the circuit, this is just about 8% of the total power that the batteries deliver to the circuit.